Christopher Texler is coming to the end of his sophomore year at Arizona State University at the age of 15. He is majoring in space and Earth exploration and is looking forward to potentially starting a summer internship. He is a member of the high-ranking Daedalus Rocket Club, and he has held an NAR Level 1 certificate since 2017. Christopher has completed the Messier Marathon. He has recently started his own business, Phoenix Suborbitals. Christopher's freshman year of college was at Embry-Riddle University, majoring in aerospace engineering. At that time, he became an active member of the Prescott Astronomy Club. He has given formal presentations to large groups and informal fun sessions to small communities on a multitude of astronomy and space-related topics. Christopher attended NASA Space Academy in 3 different divisions, and he has worked with H.D. Arrow. Born in Vail, Colorado, Christopher is still trying to understand why his skis don't slide as fast as they used to.
Quizzes, I just got on spring break. I shouldn't be taking quizzes, let alone giving them. So, is Ultima Thule a Norse phrase? Anyone, any hands up for that?
I would say yes.
Is it a random snowman? Possibly with coal for eyes. We can't really confirm right now.
Possibly.
Anyone there?
Yes. It looks like it.
Is it contact binary known commonly as MU69?
Yes.
Or is it all of the above?
All of the above.
So it's actually the object in the lower right corner, and Ultima Thule is a object that New Horizons just flew by. You'll remember New Horizons from the mission to Pluto. It recently did a flyby, I think in 2015. And so what happened is we began our search for Ultima Thule right after New Horizons flew by Pluto, and they said, well, New Horizons is still alive. Now what? Because they didn't expect New Horizons to survive much past the flyby, because the systems on New Horizons aren't that powerful. They're only a little bit more powerful than those used on the Voyager missions. And so what they did is they said, well, is there anything else out there? So they took the search field, which is basically where they thought New Horizons was, and they zoomed in a lot with a big telescope, specifically the Magellan telescope. And so you can see this is actually the raw data from the Magellan telescope, and it's quite busy. And so you can imagine looking for a 100-kilometer wide object in that large of a search field would be quite hard. But somehow they managed it. So how did they manage it? Well, as with a lot of things that we do with astronomy, we assume. So we assumed that if there was an object there, could we simulate it, maybe plot its orbit, and then look in that orbital radius? So what we did was we ran our computer simulations for an object about 100 kilometers out, or 100 kilometers out from where New Horizons was at that point, and we plotted it in our simulations, and then we looked there with our telescope, and lo and behold, with the Hubble telescope, we found an object zooming through space, quite slowly actually. It would have been in geostationary orbit of the sun, so it would have remained over the sun's rotational axis pretty much always. And then the next step from there was to plot a course. So New Horizons plots its courses using these 4 thrusters at the back here. And to give you an idea of how small these thrusters are, it would be like me dropping a grain of salt onto this table. That's how small the thrust output is. And so what they did was they had to, that actually was one of the search criteria, is it had to be really close or they couldn't get to it. So what they did was they plotted a course correction of about 1 meter per second, which is actually about running speed for a human. So you could race New Horizons out there. Of course, you'd have to get out there first. And they plotted their course there. Now, one of the things that they had to do when considering this was they plotted a course for around 35,000 kilometers as a closest approach. Now, even though we had a pretty good idea of where this object was, at the time we didn't even have a name for it, we had about a 100-kilometer error in our measurements because of how small the object was and how fast it's moving. So what we had to do was a 35,000 kilometer closest approach, just in case we might hit it if we go any closer. So then we got our first images back. Now the first image wasn't much better than what you had seen from the Hubble Space Telescope, but it did give us some idea that something weird was going on here. Mainly that it was a two-lobed body. Now this isn't uncommon, but none had been seen out this far. So as we got closer and closer, we got larger and larger and more detailed images, until eventually we got the most detailed image to date of Ultima Thule. Now, you might see why people are now relating this to a peanut or a snowman, because it looks exactly like that. And so to give you an idea that this isn't just some uncommon appearance, we actually have even visited other contact binaries in our solar system, namely the Rosetta mission. Now, the Rosetta mission was a slightly different mission for a comet that I can't quite pronounce. It's the 67P comet, and that was aimed at landing on a comet. That came from the Kuiper Belt, but it had a very eccentric orbit of the sun, so what happened was as soon as they landed, comet burned up, mission failed. But we have had experience with these contact binaries, and we have many others in the solar system. However, something interesting started happening as we started passing by it at around 1 kilometer per second. So you can see that as we go past it, we can see the crescent and where the stars were and were not. Now, this was probably about a 24-hour exposure time on the camera, just to get the stars in the background for navigation. But the scientists could also use the stars for another reason. So by telling where the stars were and weren't, you could tell a three-dimensional model of the body as you passed by it. And it turns out that Ultima Thule isn't a spheroid, as we thought it was, but actually quite flat. Now, this was interesting because beforehand, when scientists were looking at Ultima Thule, they thought, okay, we've seen contact binaries, but usually the two lobes are relatively equal in size. What's up with this one that it's like that? So the main reason why we thought that most contact binaries formed was that you had two relatively same-size asteroids, and they hit each other and did something called cold welding, where the ice on the two bodies melted very slightly from the friction of them hitting each other, and then refroze, connecting the two. Now, this would make sense for objects of about the same mass, but for objects like this, you would have a center of mass closer to the larger body. So as it spins, it would probably just throw the smaller one off. However, with this newer model, the center of mass was actually much closer to the center of rotation and the center of contact from what we observed. And so this pretty much cemented our idea of, okay, so this actually can exist, but also, wait, what's going on here? We had based our entire planetoid model on this. So what happened was it really shook up the astronomical community as far as, well, can we trust our astronomical observations from here on Earth of these? And so what happened was we actually are still getting data back from this, because the most recent data, actually as of today, I was inputting live data from this one, is this video. And so you might be asking, well, why can't we go forward with this? Why can't we look at more of these? And that's mainly because of the speed at which this data is coming in. So New Horizons, for all the data to come back, it would take about 2 to 3 years. And that's just for data transfer, not taking into consideration that New Horizons is still going to be moving away from us. So right now we're just working on based on what we've got. However, this is still a lot of really cool data. And it gives us this really cool image. So what I want to point out here is that New Horizons has 2 cameras, a very high resolution black and white camera and a very low resolution, it was actually added on as a university payload, color camera. And so NASA combined these two to create that image. However, that raised up another issue of, we thought that it was just mainly water ice. If it was mainly water ice, it would be closer to the black and white model. However, the reddish appearance suggests iron and also oxygen. And so what we are currently doing with the incoming data is challenging exactly what shape it is, because if you notice back here, we weren't even able to include the craters or anything. We just got a basic model, and that is mainly due to the slowdown of the data. And so that also shook up the astronomical community quite a lot. So some projects that are actually going to include more studies of these smaller bodies that weren't previously going to include studies of these smaller bodies is the James Webb Telescope. So the James Webb Telescope is a near-infrared telescope, about 25 square meters of observing area, and previously it was going to be using the same mission as the Kepler mission to look for stars and exoplanets. However, suggesting the new appearance of these kind of weird, is the best way to describe them, planetoids, it'll also be including looking out into the Kuiper Belt as a part of its mission. And this is a really interesting photo because you can see the gold plating. They actually were supposed to launch it pretty soon, but what happened was as they were unfolding the solar protector, it broke. They have to repair it. Also, Japan has a mission that is going out and taking a sample of an asteroid. It actually just took that sample. But what's interesting is that now they're thinking about, well, can we find this kind of stuff on other asteroids? And if so, since Hayabusa 2 is powered by ion engines, can we send Hayabusa 2 to one of these contact binaries? But what's interesting about this is that this is an international contribution. As far as New Horizons was sent up by ULA, it's an American probe, and now it's influencing a Japanese space mission. And so recently, there have been many proposals to use Hayabusa 2 for further exploration, and one of ASU's missions called Psyche is actually going to a metal version of a contact binary because we think it may be the core of a planet that the mantle was ripped off of. So, any questions?